Okay, we'll start then. Hello, everyone, and welcome to this Civo meetup webinar. And in today's webinar, we'll be discussing about mastering multi-cloud management, some of the advanced tagging techniques, expense monitoring, resource visualization, understand why multi-cloud is actually required, and how we can achieve that using some of the tools. There is a demo as well that shows you how you can actually achieve multi-cloud, and then you can use tools like OpenCost, Komiser to visualize those and get meaningful data out of it, single pane of glass, and a lot of things. So yeah, let's get started. I hope the screen and the screen share is working fine. Cool. So I'm Saiyam Pathak, and I'm working as field CTO at Civo, and that's my Twitter. Yeah, probably the crackers noise will be there because India just won and advanced to the finals of the World Cup. So ignore the crackers. So what is cloud? The As you can see, that cloud is a place where you actually run your workloads, as simple as that. It's a server anywhere in a particular region. In a data center, there is a server rack, and there is a server where your workloads are running, and that's basically clouds. You interact via the CLIs or some of the open source tooling like Terraform, Crossplane, Pulumi, or obviously the obvious one, the UI. So these are some of the ways you interact with the cloud APIs to create and access the resources which are running on the servers that are in the data centers somewhere around the world. So that's what cloud is. And there are multiple cloud providers like Microsoft, Civo, DigitalOcean, AWS, Google, Oracle. They have their own data centers, and that has its own compute capacity that which can run your workloads and own set of services. So that's very simple what cloud is. Now, while we are here, let's try to discuss that there are failure scenarios, and anywhere anything can fail, and actually things are meant to fail, right? I mean, if it's not broken, then probably it's it's just waiting to be broken over there. So this is the example where the Google Cloud slips over in the Europe due to the fire. Very big kind of outage that happened, impacted the PaaS and IaaS. AWS East one, US East one. I think I think this is the region that has the most number of outages when we talk about AWS. And yes, a lot of things are running on this particular region. So when this region kind of goes under a pressure, or stops working, then probably there are chances that a lot of applications stand still. I mean, they do not work. So, and this is AWS. So we talked about GCP, we talked about AWS. Civo had another site power outage as well, which went on for some time. And so yeah, I mean, everybody is vulnerable to some of the power outages, some of the things that you kind of cannot control because of the natural calamities or the fire breakouts and things like that. So this is where, and even the exchange online, like you use Teams, you use Slack, so you use various day-to-day business activities. You carry out day-to-day business activities with all these tools. So even these goes under outages. And even companies that adopt very good multi-cloud strategies, they also get affected by the outages. I mean, even when you are very pro at the multi-cloud, you can face outages. So yes, the point I'm trying to make here is, so we started with cloud. I told you some of the outages. Why was that? Is multi-cloud is something. Yeah, this is cloud. This is fine. So Services go offline, and we have discussed there are various regions. There can be vendor outages that can be related to the services that are provided by the vendors, and there can be some sort of issues with the compute network storage or whatever services that they are providing, or hardware issues or network issues that lead to some of the outages. Yes, there can be targeted attacks that can be there, like the DNS attacks that can be there on some of the compute instances or some of your workloads. Unpredicted traffic sales. So whenever there are big holiday season going on, Christmas going on, or the famous the Black Friday sale going on, so you can have the unpredictable traffic, and that can lead to services not being able to handle those traffic and can go offline. There can be software bugs inside your software. There can be human error that can be there, that can lead to the services going offline. If you push some code and you haven't battle tested well, it can lead to the outages. So that is where we have cloud. It's fine, you're running on one cloud, it's fine. There are outages, and there is no single cloud that that is like forever running and they had never had any outages. It's just a matter of time and things go wrong. But you, as the developer, as the creator of your application, or the services that you provide, and you are building on top of cloud, you actually have the liberty to choose and use multi-cloud. So multi-cloud is definitely the art of not putting all your digital eggs in one cloud basket. So like we saw different cloud providers in the data center image. So this is what you can use. So all the cloud providers have their own set of services that they provide, and their own set of unique flavors that they add to make the unique experience for their customers. So that is where, as application developer, I am free to choose which particular service I want to use, which particular cloud I can go with, and there can be various parameters associated to that. There can be a cloud service that provide managed Kubernetes offering, and you get your Kubernetes cluster under 2 minutes. Actually, that is Civo. So you can go with that. If you are looking for a cost-effective solution, you can try to measure the cost for a particular service for different cloud vendors and then go with that. There can be performance improvements that are being made for different cloud providers. So you can go with one particular service, check the performance, like for example, storage. So if you want to check the IOPS for the storage, you can go with different cloud providers, use the same kind of capacity over there and try to measure the performances of the IOPS that is there with respect to different cloud vendors. And if that particular metric is very critical to your workload, then probably you choose the one which has the highest IOPS given. So that's where you can choose. But yes, multi-cloud is very useful. It's similar to what I call, and like we adopted DevOps as a culture. So it's similar to that. We need to adopt multi-cloud as a culture. Like it has to be embraced within the team, coming from the leadership team, dwell within the organization, that this is the regular practice that we'll be doing of doing multi-cloud. And then definitely it reduces the chance of external issues, reduces the impact of human error. But it's not as simple as it sounds, because what happens is when you create your application, you tend to use a lot of vendor specific services. And when you are using those vendor specific services, you get tied to a specific vendor. So let's say you use IAM, then you use a specific flavor or database, then you use specific flavor of another service, and then you get tied to that ecosystem so much that it's very much difficult to get out of that ecosystem. And even if you try to get out of that ecosystem, you won't be able to sometimes you won't be able to pay for the egress fees, like the data transfer costs. So there are a lot of factors that you need to consider before that. But yes, when we say about the cultural change, and we try, because innovation will not stop, right? If you are an organization, you will keep on creating your new microservices or your new set of applications. It's not that you just have one small application and you're just running it forever. You'll keep on creating those applications, and for the new applications, at least you can go multi-cloud. You can set a strategy that this is how we'll go multi-cloud. This is how we'll try to handle the disaster recovery. This is how we'll try to handle the cost metrics. there can be global recessions that we have seen that in the past. So if anything comes boiled down to the cost perspective, let's try to fix those with the new set of applications that we have, or even the dev environments, stage environments, because there is production, but there are other set of environments as well. And each of the environment you can have on different set of clouds, and try to mitigate issues or try to have, cost benefits or performance benefits and so on and so forth. Yes, data locality is another thing, and then technical skills and experience is another thing. You in a team, it's difficult to have a knowledge, like for example, you hired someone who is amazing in one particular cloud, they know AWS in and out, and suddenly you want to use another cloud vendor, so there is a technical skill gap as well. That needs to be filled. But again, if it comes in as a cultural practice, then probably things will go in the right direction. So, and cost again is something, egress fees and things like that need to be considered when moving multi-cloud. So those are the things which makes it very difficult. Also, one thing that troubles people is a single view. So when you go multi-cloud, you end up creating so many resources. You end up creating networks, you end up creating firewalls, you end up creating load balancer, you end up creating the actual resources that can be compute, Kubernetes, then your logging services, and then IAM, and then some of the other roles that you are actually using. So, and that is just one cloud. And imagine that if you are using three clouds, and three clouds is common. Like it's not that people don't use three clouds. People use multiple clouds. I have been like when I was working on the machine learning platforms long back in my previous organization, I was using multiple clouds, and we were having different set of platform. We were using on-prem as well. So, and that's a own kind of private cloud that you can call. So we were using, but the struggle for having a single view of all the resources is was there. So, but yes, now there are tools, and we'll be discussing like I have Jake with me, who will be discussing more about Komiser tool that gives you a single view of all the resources that we are using together from different cloud vendors. There are other tools as well. Then unified billing. This is also very important. You need to understand the bills, and each cloud having separate resources, having separate billing structure, having separate billing information for specific resources can lead to so many, discrepancies in when do you want an alert to happen. Like what is your budget and what is your overall budget, cloud budget, and where you want to put an alert on. So then that becomes cloud specific. Expense monitoring, which team, dev, stage, or prod is using which services of which cloud and how much they are costing is another thing that people face issue with, or teams face issue with. Just quickly want to go through some of the cloud, some of the FinOps specific things. So FinOps is an evolving cloud financial management discipline and cultural practice. Again, the cultural aspect will always be there, that enables organizations to get the maximum business value by helping engineering, finance, technology, business teams to collaborate data-driven spending decisions. Why we are coming to the FinOps side and the cost side? Because this particular talk is, this particular webinar mostly emphasizes on the resources that we see, the tagging and the cost aspects of it. So by now, you should be clear like what multi-cloud is, what are the benefits of multi-cloud, and what are the hardships of actually doing multi-cloud. Now, for some of the things, we do have a solution, which we'll be definitely demoing you, and also like how to do multi-cloud. So this is like, you have a shared responsibilities between different team structures, just like DevOps is a shared responsibility between the team. This also becomes kind of a shared responsibilities between the team, and we have different cloud vendors over here. You have key metrics, that is project cost, team cost, what is the cloud project, what is the spend per project, what is the spend per team. So that becomes part of the overall budget. Some parameters that you should kind of watch out for, parameter tuning that you can do. I mean, these are apart from the single view and all that things that we'll be discussing about. But yeah, few of the things which are common. And yeah, one thing I want to add which I missed. So Kubernetes and cloud native. So when we talk about cloud native, Kubernetes definitely come into picture, and there have been a lot of talk as well of whether Kubernetes is cloud native or not. In my opinion, yes, Kubernetes is cloud native because actually Civo is actually true Kubernetes, cloud native service provider. We have the base layers of Kubernetes as well. So Kubernetes is that such tool that actually gives you that level of abstraction that helps you to easily go multi-cloud. So when you talk about containers and you talk about the Kubernetes cluster, so if you have containerized workloads and you're running on one Kubernetes cluster, so you can actually have a DR setup very easily set up on another cluster. And it also has a unique set of APIs, like which are same. So the same set of APIs are there for Kubernetes. So if you want to create a resource, there might be different, but like, for example, you are creating a service type load balancer. So you, irrespective of whatever cloud you use, whether you use Civo, AWS, GCP, you will be creating a service. And in that spec section, you will be typing type as load balancer. So your spec remains standard. So your spec remains the same. It is cloud agnostic. You haven't changed the spec when you are moving the clouds. The other parts which are there cloud specific, that are automatic, because when you use the managed Kubernetes, the cloud controller manager that helps you get a specific public IP from the cloud specific resource and map that to the service is cloud specific, and you don't have to take care of that. So you can actually have the same specs, replicate that in another cloud provider, and because those are remain the same with storage, you can have defined the PVC. So you'll be saying in the PVC section that which is the persistent volume claim. So you will be telling in the persistent volume claim that this is what are the resources that I need. This is the amount of resource that I need. And then it's the storage class for that particular Kubernetes cluster that is there that will be able to give you the persistent volume for that specific cloud provider and map it. So the mapping of the PV to PVC remains the same. Only the provisioning of the resources depends on the CSI driver that gets installed cloud specific, but you don't have to take care of that because that is cloud specific thing. Your specific thing is Kubernetes manifest that you have created. So once you have the Kubernetes manifest, you can do multiple stuff. So yeah, that was one thing I wanted to add. Kubernetes definitely helps when you are moving multi-cloud, and it's big differentiator over there. Then compute network storage, definitely have an eye on these. Like when you delete a compute instance, there are certain aspects that remain over there. So you need to see, that's where the resource visualization is pretty important. Like if a volume is staying even after you delete something and it is costing you money and you don't even know because you forgot to check. Maybe you have the budget or billing alerts over there and just tell you that you went over the budget. But a single view that gives you like, okay, you have these many resources and you can see, oh, this is a volume. I have never used this volume, or this is a free volume, which is there, which I can delete. So if you have those views in front of you, it becomes easy to delete that. Then try to use the recommenders, try to use new instance types for the network as well. Make sure you remove the unattached network, and that there are data transfer charges and the NAT gateway charges. And make sure in the storage, you don't have any unattached PVs, which you don't need. We don't provision extra volumes, and you do the right sizing of the workloads. Log retention, make sure to have the log retention right, because that can lead to very heavy charges once, logs keep on getting built and built and built over the period of time. And then Kubernetes, resource utilization, auto scaling, incoming request trend, all the cool stuff that you can do with Kubernetes, you should be doing. So that is something on the parameter tuning side of things. So yes, when we add the layers, we have Kubernetes layer as well. So when we add Kubernetes complexity, it does solve a lot of problems, but it does add to a lot of complexity as well to the ecosystem. So it adds the layer of abstraction, you get node costs, but what about the workloads which are running over there? Yes, there are tools out there that you can use, which definitely I'll be telling you. So you can use some of the auto scaling, predictive auto scaling, resource budgeting at the namespace level as well. So other recommendations are like obviously the alerts, AWS Cost Explorer, budgeting allocations per project, and all these things are pretty much there. Yeah, coming to the tools. So these are some of the tools which are there. OpenCost, it's a CNCF, it's part of the CNCF, and Koku, OptScale, I think, is a complete platform. Komiser has been, like I talked about Komiser maybe at the start of the year, and I have seen that it has been growing and growing and growing since then, adding more and more integration. There is a new dependency graph as well that Jake will be telling more about in detail, like what it means, how it helps. Tagging of the resources is something which we'll go in detail later on. So it has evolved a lot in this particular space, and that is also open source that you can use and contribute to. So OpenCost is a vendor-neutral open source project for measuring and allocating cloud infrastructure and container costs in real time. Built by Kubernetes experts and supported by the Kubernetes practitioner, OpenCost shines a light into the black box of Kubernetes spend. This is the definition from their website. So I have nothing to do with the definition that's written over here. But yeah, let's look at some of the demos. Let me share. Okay, I think this screen should be fine. Let me tell you what all stuff is going on. So this is OpenCost, and if we go here, OpenCost GitHub. So that's the repository for OpenCost GitHub. If I go to opencost.io, and you can see the get started. It's pretty simple on a plain Kubernetes cluster. So what I have done over here is I have taken a Civo Kubernetes cluster. I have installed this Prometheus over there, and then I have installed the OpenCost, and then it's just the port forwarding which I have done, and that is the screen that I'm getting for this. Yes, this is like this was first initially built by the folks at KubeCost. So KubeCost itself is a very unique platform that they have. They internally use OpenCost definitely for some of the things, and additional things on top of it. So it tells you, by breakdown by namespace, breakdown by service, pod, container. So the workload metrics that I was talking about is something you get a good view in the OpenCost. Although OpenCost is not like, you cannot do the settings of the costings and stuff. I mean, you can do, but it's not directly from the UI. Yeah, it tells you a lot of good things, at least what is the total cost, efficiency, and you can, I think, change the cost as well. And per namespace, it gives you all these details. Coming to multi-cloud thing. So there is a strategy. So this is a particular demo that Dinesh, who is our CTO, gave at KubeCrash. So this particular demo actually shows how you can deploy multiple clusters in multiple regions using Terraform. So basically, what I want to tell you over here is, you can have Terraform, or you can have any IAC tool like Terraform Crossplane. I actually have a Crossplane example as well. So OSS, yeah. So this is the example with Crossplane. You can install Kubernetes cluster. So you can install a Kubernetes cluster, install Argo CD, install Crossplane, have two repositories for it to monitor. One can be infra and another is the Argo. As soon as you create the cluster.yaml file in the infra, Argo CD will automatically apply that onto the cluster, and your cluster will start provisioning. So that becomes your infra automation that is there. And then you can have something which is called application set. As soon as you are tied, you can have the application set over there. So that is something which is there. And this is another one where you can use Terraform as your infrastructure as code tool. And then you can use Argo CD application set to deploy the application onto the cluster in different regions. So this particular thing, you can just go here and you can put a make command, and you just type make, and it'll ask you for your Civo token, and you can just enter the token. It will automatically create two clusters for you, one in London region and one in NYC region. And then it will be installing the application using the application set, which is over here, and yeah, cert manager as well. So that's the app set. So that's the application set that it will be installing over here. Now, this is how it looks like in Komiser. So I'll leave all the nitty-gritty details for Jake to handle, like what all the UI, what all the fancy things Komiser can do. But a few things that I have done is I have installed regular Komiser. I have given a file. Maybe Jake can talk more about the config.toml file that is there that you have to do. But when you do all the things and you have configured Civo to appear in Komiser dashboard, this is how it looks like. And what I have done over here is I have tagged two resources. So first I have added filters. So I added a filter of a cloud service Kubernetes, and then cloud region NYC or London one, because that's where our multi-cloud resources were deployed. And then I added a tag specific to it, and then I created a view of it. So as soon as I go to this view, I can see that I have two clusters, NYC and London, which have deployed one specific application, and this is the cost that has been allocated, or that it's being used for this particular resources over there. I think this why I have shown this. So this gives you a picture that you can do multi-cloud. For this, we have done multi-region, but you can use the same pattern for Terraform or Cloud because it's IAC, right? You can just have different set of providers, and the specs will change, the Terraform files will change specific to the provider's resource that you want to create. So in this particular scenario, there is a Terraform that will create all these resources for you in different regions and then deploy the applications over there. And then to visualize it, you can have a dashboard, a single dashboard that Komiser provide. You can tag those resources because tagging is pretty important. You can tag those resources, and using those tags, you can create views. So if a person who only wants to view the multi-cloud things that are happening, or the application or the multi-cloud applications that we are doing, we just go to the multi-cloud view and it lists down all the resources consumed by the multi-cloud applications. So that's pretty much it that I wanted to show from the multi-cloud perspective, and from Komiser how you can actually do the multi-cloud stuff over here. We link this particular repo as well in the chat. And now I don't know if I have any other slide. Yeah, that was the demo. So you have GitHub repository. You have one cluster in London, one cluster in NYC. You get all these cluster, Argo CD, Cert Manager, everything installed over here. That's done by the Terraform. These are the two. This is how the repository is structured. So you have Terraform repository that has all the layers of London and NYC and the overall infra, how it looks like, taking from the variables values. And then you have Argo CD that has the Argo CD specs and the Cert Manager plus the application set. That is your application that gets deployed across multiple clusters. So yeah, I mean, that's how Kubernetes helps in the multi-cloud thing. And that's how some of the tooling that you can use with respect to the overall ecosystem. You can there are actually other tools as well. Like if you can have, like if you want single sign-on over there, so you can have something as a single sign-on platform, and then you can tie it to multiple cloud providers, and then you can have different views, and then you can have different access to different views with respect to different cloud providers that are used by different set of teams for different projects. You can have budget set by projects, budget set by, I mean, grouped by projects, grouped by cloud. All these things are doable. So I hope you got a gist of what multi-cloud is. Wanted to set the context before Jake goes deep dive into some of the aspects of how Komiser can help you in achieving all the advanced techniques with the tooling. So over to you, Jake.
Perfect. Thanks a million. Yeah, thanks a million for the context. I'm just going to share my screen so we have something to look at while I jabber on. Yeah, also I can see, I can't see it now. Let me just grab the chat just in case there's anything that comes up during the talk. Let's see if I can find it here. Yeah, perfect. So yeah, I can see the chat. If there's anything that pops up, please feel free to let me know. And thanks a million, Saiyam, for the context. I think it was very useful. You're saving me a few slides here. And thanks a million for pointing out FinOps and the kind of like growth of the practice of FinOps and how important it is to kind of like understand how we can kind of like contextualize issues around multi-cloud management. One of the interesting things for those who don't know that much or are probably new to FinOps is that FinOps kind of like revolves around these three main phases. The inform phase, the optimize phase, and the operate phase. And it's interesting to have these clear because there's a bunch of tools, Komiser being one of them, that are being developed to help with multi-cloud issues, and some tools try to cover them all, and some tools are trying to specialize. For this conversation, I think it's helpful to know that Komiser tries to help out as much as possible only with the inform phase, and we'll look at specifically how that translates. So let's just go quickly back over. I'm just going to turn into front of slide. So just touching again on those unique challenges that come with multi-cloud management. By no means do we think that any particular tool, and especially not Komiser, is going to help with every single issue that might come up with multi-cloud. As you well put out, there's so many different issues that can come up. But when we think about that informed stage of the FinOps phase, a few things kind of come up that we try to help as much as possible, mainly revolving around cloud transparency. So that's shedding light on cost, giving insights around resource inventories, trying to solve this multi-console, multi-pane view that we have kind of like by default into our multi-cloud environment, simply due to the nature that if we have one workload in AWS and another service that we're leveraging in Civo, it makes sense that there's not going to be a single default pane to help with that. So we're going to need a third party, and that's why we try to make that as seamless as possible. Also, another thing that is kind of difficult when talking about multi-cloud deployments, multi-cloud environments, is that teams that are working in those different environments might miss naming inconsistencies, tagging inconsistencies, and there isn't very easy ways of finding how to address that. So having a single pane that does the work for you of gathering everything is very, very important. Just to put some data points on the table so we can kind of frame the conversation a little bit further. When it comes to the cost concerns inside of this informed stage, we can see the trends, and I'm just grabbing some data points from the Gartner, Cloud Zero, and Flexera, and also Stormforge, which are reports that were put out last year. Here you also have a link to an article. I'll be happy to share this presentation later on to have access to this, but it cites a third of cloud computing spend goes to waste. And anyone who has probably worked in or kind of interfaced with cloud environments can more than likely guess why, especially once cloud environments start growing. No one on purpose is going to try to waste any resources, but when environments grow, it's kind of hard to know exactly what is being provisioned, what's being used, with the development of new features, with the development of new products. Deprecated services might go unnoticed, and it's quite hard. So in the excerpt here from the article, it mentions that better management of resources could hinge on establishing multidisciplinary teams to make decisions around cloud workloads. And I totally agree with that, but those teams are going to need some kind of custom tools that are going to help specifically with these kind of problems. And I think a mindset change is also quite important. And I'm going to be fully transparent. I'm going to try out this analogy with this audience. I've never tried it out before, so please let me know in the chat if it doesn't make sense. I'll be happy to know. But when we're talking about cloud engineers, developers, SRE engineers, DevOps engineers who are trying to manage the best way possible their multi-cloud environments. It's all about trying to gather, and again, especially talking about this informed stage of the FinOps workflow, it's important to try to get as many insights that are actionable as possible. And if you are going about getting these insights, say, for example, where are all of the provisioned resources? If there are resources that need to be deleted, how do you get them? If the way that you're doing and you're moving towards those insights is active and iterative, so say, for example, going into clicking buttons in the cloud console, sorting through the regions, looking through that way, you're kind of more of a gold prospector. A gold prospector is someone who kind of travels from creek to creek, from mountain ridge to mountain ridge, very actively panning for gold in each spot and then moving on to the next. Whereas a shepherd is someone that has a very clear goal and rarely breaks a sweat to get it done. A shepherd uses tools that can enable them to be quite passive in their approach. They have to fetch their resources, which in their case are sheep, and they use sheepdogs and well-trained sheepdogs that go out. They fetch the resources and bring them back. And while they didn't break a sweat, what we should try to aim towards is, as engineers, try to leverage those passive fetching mechanisms to be able to, as easily as possible, grab everything that is in our cloud environments, be it a single account or in multiple accounts inside of the same cloud provider, or in multiple accounts in different cloud providers. We shouldn't need to go out and click through all the consoles, click through all the regions to make sure that that everything that's provisioned is covered and under our purview and on our radar. So yeah, I think I need to still work on the analogy a little bit, but that's what came to mind when thinking about this. So just to contextualize some situations that might make it a little bit more clear what I'm talking about. These are some of the issues that might come up if you don't have a clear strategy, an effective tool to manage the gathering of these insights in a multi-cloud environment. So the first is a case in which you have a legacy service which is being deprecated in your organization, and there are hundreds of object stores across multiple regions that need to be deleted. You don't necessarily know which regions the stores are in, but you're tasked with getting rid of all of them. I mean, I'll open this up to the chat. Without which would be the easiest way to do this? I remember once at a previous working at a previous company, we had to do exactly this. There was a deprecated service, and we needed to delete a certain number of S3 buckets, but we didn't know exactly where they were. So it was a very, very painstakingly boring and iterative process of going through all the regions and making sure that all of the S3 buckets were gone. I'm sure there's also like customized scripts that you could write for this, but what we propose is two particular features that we'll look a little bit later on, but the potential solution is around tagging through Komiser, and also creating a filterable resource inventory, which we'll look at. Just another kind of make-believe situation here is that you're a cloud engineer and you want to start pushing your developer teams to be a little bit more budget aware and report the cost that's incurred by the services that they build and how their squad contributes to the larger cloud bill. Of course, it's important, especially in the informed stage of the FinOps workflow, regardless if you're paying for it or not, but at least to have the awareness of what is contributing to the overall budget, and trying to, through that knowledge, and through that awareness, kind of make better decisions about budget allocation. So which would be the easiest way of doing this, and which would be the easiest way of knowing if a team went over budget? And of course, I know that a lot of cloud providers have alerting systems for their accounts, but what happens when we're talking about larger workloads that are in these multi-cloud environments? It becomes a little bit more difficult to alert, and it becomes a little bit more difficult to create this awareness. So the potential solution that Komiser tries to bring is the creation of custom views and alerts that are applied at this custom view level. If this means nothing to you right now, I totally understand, but we will get to it quite shortly. And just one last example that I wanted to touch on is you're an SRE and your environment has been going through a lot of changes recently. There's new engineers coming on, and there's new features being developed, new region expansions. How can you discover all of the provisioned resources and make sure that they're still in use? And how could you do this depending not only on memory and compute usage metrics? Because again, if you're looking at compute and usage metrics, these metrics are always kind of limited to the account that you're looking at. But how do you know that the usage metrics are that you're covering all of the resources provisioned in your accounts in all of your multiple cloud providers? So having touched on these situations, and just lastly, to touch on the fact that a potential solution for this particular context is the resource dependency graph, which Saiyam also touched on, which we'll get to now. I think this could be a good time to jump into the demo. I'm just going to exit from here. So if you have the chance and want to check it out, head on over to GitHub, where you can find the Komiser repository inside the Tailwarden group here. And yeah, you can head on over to the documentation, which is at docs.komiser.io to get started. Just a quick bite-sized overview of how this kind of came to be. Mohammed Lobardi is the CTO and co-founder of Tailwarden. Previously, he was a lead DevOps engineer at a large enterprise company in France, and he was suffering. There was an initial growth into a multi-cloud environment, but he was already suffering from just the multiple accounts inside of AWS that he had to manage. So he started building Komiser on his own, just simply trying to get a cohesive and straight to the point resource inventory. And now Komiser, a few years later, is pretty much completely community based and built and contributed to. At Tailwarden, we do try to kind of like give the open source contributors the most amount of support as possible, but we're pretty happy to report that this is pretty much built by the open source contributors, and we're very, very happy that that is the case. Having said that, the way that you would start interfacing with Komiser is by downloading the binary. You can install it if you have, you can grab any of these installation commands, or if you have Homebrew, just simply grab the tab there and then brew install Komiser. Once you have the binary installed, we need a way to authenticate to our cloud providers. And we do this through the config.toml file. For each cloud provider, there's a different set of credentials that you need to add. Let's quickly head over to Civo. And before we look at the actual credential that we need, we can choose between two different data persistence methods. You can provision a Postgres database, or you can just keep it simple and provision just with this line the SQLite file. This is where all of your resources are going to be stored, and every time you fire it up, you're going to have your persisted data. Having said that, inside, so just above the data persistence, method, you can add your cloud provider segment where you'll give a name. You can choose this doesn't have to match the name that you have inside of your cloud provider. And for Civo, you just have to create your API token. You can link down or watch the video on how to do so. I have a SQLite file here, and I already have a couple of config.toml files right here. Let's just go straight in, and we're going to start off by simply authenticating to a single account, and we'll see already that we'll have a good few resources, and then we'll talk about a multi-cloud deployment of Komiser. Okay, so since we're going to run this single account now, I have a single account in. Sorry, I'm going to pass in the config flag, and then I'm going to pass in this this particular config file. We can see that resources are being fetched in the background. Let's head over to localhost 3000. Resources are still being fetched in the background. It might take a couple of seconds. As we can see, we have resources in 3 different locations in New York, in London, and in Frankfurt. We can see that we already have 51 resources here. And down here, we have the Cost Explorer. Since this is a new data persistent, a completely wiped and new database, we don't have any historical data. We just have the data that we have right now, this month in our Civo account. So you're only going to be able to see this, but with future kind of deployments and future runs of Komiser, you'll start seeing the historical data right here. Okay, so let's head over to the inventory page. So as you can see, without really doing anything, like taking the shepherd's approach, we have a full list of everything that's inside that particular account. But of course, a long inventory list isn't really that useful in and of itself. So just to get you started with some insights, we have these 2 default custom views. You have the untagged resources and the expensive resources. So this is any resource that costs over $0. But at the moment, this is only limited to the cost metric. But in our case, we want to know exactly all of the Civo resources that that cost over $1. So let's go ahead and just build quickly that custom view. So we've applied the filter of cloud provider Civo, and anything that is greater than $0. Perfect. So we have these 4 resources at the moment. We have 2 compute instances, 1 volume, and a database. Cool. Let's just save this as the expensive Civo resources custom view. Perfect. So this is now saved. The cool thing now is that any additional accounts that we add now are going to automatically kind of fetch the resources, and anything that fits inside of this particular filter is going to populate. So let's go ahead and do that. I'm going to move, instead of just authenticating a single Civo account, I'm going to authenticate 2 and some other cloud provider accounts. So I'm just going to simply pass in, I want to run this config.toml file, and since that's the default file that Komiser is looking for, we don't need to pass in the config flag. So I'm just going to simply pass in Komiser start. And as we can see, we have a bunch of different resources that are being passed in now, some of them being AWS. So let's take a look at the dashboard. So we can see that we have some AWS resources, Civo, OCI. Cool. So let's head back on over. Well, we can actually see, heading over to the cloud accounts section, all of the resources that are being added. We have the Civo prod account and the Civo dev account, as well as these other cloud providers. Okay, so let's head back over now. So we have many more resources in the inventory list, but again, this is a very long list and you'd have to go through it. So we still need to continue building the insights. But at least for now, without changing the custom view, we can already see that the resources from the dev account that incur cost inside of Civo have been added. So this is already a kind of passive, very shepherd way of going about things. Anything that we've added that fits our custom view is going to match and be automatically added. So let's go ahead now and just build some other insights that might be useful. So heading back over to all resources. As we can see here, Civo has a bunch of resources that pop up in our account, even though we're not necessarily using them, which are all of these disk images. So these disk images, if I understand correctly, they're available to us. We can assign them to our compute instances, but at the moment they're not incurring cost. To be honest, we don't really need to see them, right? So let's just build another custom view in which we're going to specifically say which are the important services for us to track. And I'm just going to choose, for example, compute instances, volumes, databases, and I'm also interested in Kubernetes clusters. Cool. So these are the important Civo resources that I want to have tracked. So let's just create this important Civo resources. Okay, so I'm just going to save this as a view, and imagine that we wanted to have some sort of kind of like change log on a week-to-week basis, on a day-to-day basis of the different resources that were created in our environment that match this particular filter. We can now head on over to the download CSV file, which is going to give us exactly what matches the custom view. If you wanted to have this kind of like change log sent to you on a weekly basis, you would be able to do so. And that way you would be able to kind of like track from week to week or from whatever cadence makes sense for you, the changes that are taking place inside of your environment. But say, for example, you have a pretty broad but useful custom view, but there's a couple of services that really aren't that useful to you. So say, for example, you don't really want to include in this change log and this important Civo resources list, the dev resources. So you can just easily choose the services that you don't want to include and hide them from the view. And if you were to create the CSV file now, you would have an updated CSV file excluding the hidden resources. So that is something that's available to you too. This comes to mind if you want to build out reports for the finance team, if they need to be aware on some sort of a weekly or whatever cadence of certain information. Speaking of finance and speaking of one of the use cases that we touched on at the very beginning, which was how do we know how if something does go over a certain amount of our budget, how would we know? Do we need to have Komiser open all the time? Well, no, obviously not. Say, for example, here we have the expensive Civo resources list. We can very easily add an alert. And there's two types of endpoints that we can send this alert to, Slack being one of them, and we can also add a custom endpoint here to take any action that we want. Just to quickly touch on how you would set that up, you can head on over to the guides section, and under alerts, you will find the instructions to set up that particular Slack integration. I've already created the integration and I've added Slack to my config.toml file, so I can easily just go over here and create the first alert. So I'm going to want to know if anything over, say, for example, so yeah, let me just call it costs are getting scary. And anything that's over $10, I want to know, and I want to be alerted. So by setting up, sorry, I have a spelling mistake there, but you get the you get the idea. So just so you know, if you set up an alert and you want to test it out and you just want to see if it works, you probably won't see it until the next run of the Komiser fetching process, which happens on an hourly basis. So to kind of like kickstart this, let's just stop the process and restart it. And I'm just going to open up my the Slack channel that I've added the alert to. And there we go. We have a new alert that just came in with the expensive Civo resources custom view. That's the one that's the custom view that it's been applied to, and we can see the alert come in. So this is also something that could be helpful to your developer teams. One last kind of type of alert that I wanted to touch on also is the resource alert, specifically when we're talking about Kubernetes. We have a bunch of different clusters that at times we want them to be we always want them to be resilient and always giving the best service as possible. So they're more than likely going to scale out if the traffic requires that. So let's just make sure that if there is a scale out, if it goes over what we're expecting, for us to also know. So of course, we could search for the Kubernetes cluster at the moment, but let's just imagine that we have some resources that fall under the Kubernetes umbrella. Let's just quickly say, for example, Civo and AWS, and let's just I was going to grab some AWS resources too, just to kind of show that we can aggregate through tags resources from different sources. But let's just we already have some tags there. Let's just add some tags through the bulk tagging button right here, so we can add tags to these 4 resources, and we're just going to give it the key case and the value prod. So now we can kind of play make-believe and simply create a custom view filtering by the specific tag, which is Kate's prod. And cool, and we can call this our prod Kubernetes cluster. And say, for example, we know for a fact that we don't want this Kubernetes cluster to scale out to more than I don't know, like 10 compute instances. That would probably mean that we need to check out the instances that are being provisioned if there's enough kind of compute, if we want to keep on scaling out horizontally, or maybe we might start consider scaling vertically. But we could create a resources based alert, and I don't know, call it scary scale out. And yeah, for any resource that is, for any scale out that goes over 5 resources, we would then get alerted. So that is these are some of the ways. Of course, there's a bunch of different custom views that we could build, filters that we could choose to apply to the resource dependency graph. This just depends on your teams, your specifications. But I'll pause right there before we touch on the last aspect to see if there's any questions. But if not, we can move on. Saiyam, any questions?
No, I think we are good.
Perfect. Yeah, and I'm aware of everybody's time, so I'll go a little bit quicker now. But the last thing that I wanted to touch on is, again, we're still inside of this inform mindset, but it's kind of interesting to think, and I was thinking of this saying that kind of summarizes what I'm trying to say, and the saying is the following: there are known knowns, so these are things that we know that we know. Then there's also known unknowns. So there are things that we know, and let's apply this to our cloud environments. We know that we probably have some compute instances, maybe some databases, and we might not know if all of them are like where they are. There might be some resources that we don't know about. So there are some knowns that are unknown, and then there's also unknown unknowns. So these are things that we don't know about. To be honest, at this point, Komiser is not going to be able to help you with the unknown unknowns, but we can try to help you with the known unknowns. But it's very, very hard to give you any insights about the resources that you don't know about just from a list, right? So that's where we shift the Explorer. So over here in the Explorer tab, we have this feature which we call the Resource Dependency Graph. Here we have kind of a different way of visualizing all of your resources. To be honest, this could be kind of like a psychedelic experience if you don't apply any filters, because when we're talking about multi-cloud environments, we're usually talking about a large amount of resources. So let's just filter this a little bit more granularly so we can start making sense of what we're looking at. So I'm just going to filter specifically for all of my Civo resources. So right here, we can see all of the resources inside of our two Civo accounts. So this is Civo Prod and Civo Dev. Here, without even looking at the resources themselves, we know the dependencies that they have. We know how they're linked, and this could give us some interesting information at first glance. But let's just dig a little bit deeper. So we can go over to each kind of cluster, and down here we can see the group to which they belong to. So we have a compute. This is more than likely a security group, I'm guessing. Here we have or a network. Here we have the instance itself, the firewall, we see that it's connected to a database. We can also click on the nodes themselves, and we get a little bit more information. We get some cost. We get the tags that are applied also. The idea here is that, say, for example, here we can see that this compute instance is connected to the database. But it would be really interesting to know, like, if we see suddenly over here a compute instance which is not connected to a volume, which isn't connected to a database, and that would probably warrant us digging a little bit deeper to see, is that resource still being used? Just a quick note also that this is the V1 of the resource dependency graph. We would love to be able to add more, and we will add more granular filters. At the moment, we can't filter by tags, for example, and things like that. And also, it's going to be very important, and I think it's going to help a lot to be able to determine at a single glance, once we ship some specific color coding, to be able to at a glance see what nodes incur costs and which ones don't. Because if we can see which nodes incur cost, and if there's a node over here that is not connected to anything, it doesn't have a dependency, more than likely it shouldn't be there. So that is another insight that we can look at a little bit more granularly. So the idea here, just to finish up, is to give you a different view of your multi-account, of your multi-cloud environment, multi-account in some cases also. And through that, to be able to kind of like hand you in a silver platter in a little bit easier fashion those cloud insights that are going to make a difference. That's what I have for you. I'll leave it there. So I'm happy to take any questions if there are any.
Not really that I can see, but yeah, I mean, thank you so much for showing the dependency graph and some of the other nitty-gritty details that you have shown in the demo. I think that should really help in understanding what the tool actually can do, some of the advanced tagging techniques, how the views help, and all those stuff. And yeah, definitely more things coming to the dependency graph, where you can filter by some of the other cool things, the tags, to get even more granular. Yeah, I think that's pretty much it that we had for this particular webinar. I hope you understood a bit about multi-cloud, some of the challenges, how you can actually achieve it, examples, and some of the demos, walking through how some of the open source tooling can help you achieve in visualizing stuff when you go multi-cloud. If you have any questions, feel free to drop them in, reach out to us over Intercom, or even drop them in the comment section of the YouTube. We would be happy to take them. And yeah, thank you so much for tuning in, everyone.